on augmenting drones and artificial intelligence for Powerline inspections. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers or panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the KZN Centre playlist. This channel is updated regularly and you'll find the registration link in the chat box. Please register, it's free. A certificate of attendance will be issued a few days after this webinar. I'd like to introduce you now to our host for this evening, Mr. Richard Alschlager, who is the chairman of the SAIEE KZN Centre. He is also the Technical Director for Energy, Resources and Manufacturing Projects within Zutari. He is considered a multidisciplinary technical generalist on many aspects of power transmission, generation and distribution, and has the practical design and project management experience in both substation and line projects. I hand you over now to Richard.
Hi, and thanks, Minx. Good evening or late afternoon to everybody. And it's really a privilege to be hosting this and also to have Sianda here, who I'll introduce shortly. Just on behalf of the SAIEE KZN Natal Centre, it's quite an active centre. There's a lot been happening. We've got visits off to factories and things happening throughout the year. There's an active student branch operating at multiple universities. And so there's been quite a lot happening with us this year. We are coming to our year end. We will be sending out invitations for awards that the SAIEE present. So there are several different categories of that. There's Young Engineers Awards for some of the young engineers that have just demonstrated great skill and entrepreneurial innovative solutions in terms of the electrical engineering. And there's Women in Engineering, and we have academic awards and a major project award for significant projects that have come out of KZN to enhance electrical engineering and the profession. So please look out for those and please be active in submitting. There's some decent prize money, and it's just really good on the CV as well. So I would encourage that. And then I also want to just draw your attention to the handout section in the app. So you'll see there's the Training Academy brochure and a WhatsApp for October 2023. And I really would encourage you to have a look at that information and just get yourselves involved in the profession. And if you would like to become more involved in what the centre is doing, you can just drop a note in the chat box and someone will make contact with you. Anyway, enough of this. I'd like to, Miss, can you just change the slide? Thank you. It's my pleasure to just welcome Sianda Biela. So Sianda is a senior research engineer at Eskom. He's working in the T&D section, RT&D, and this is about the implementation of drone technology. I see it's quite a popular, we're going to have quite a fair amount of attendees, I believe, on this. And I'm really excited to see what Sianda is going to share with us. I'm also been active in the T&D space. So let's have a look at this. And so Sianda, I'm going to hand over to you, and I'm really interested to see what you're going to have to share with us today. So without further ado, Sianda, let's hear what you...
Good afternoon, everyone, and I would like to thank SAIEE KZN for this opportunity for me to talk to you guys, so everyone, and reach a wider audience, just to share what we are doing in terms of incorporating drones and AI into a pool of tools that we use to enhance our operations here at Eskom. And this research topic is not specifically for Eskom, it's also applicable worldwide. So I'll share some of those things. With your permission, I would just like to switch my camera off just to save on the bandwidth. will just switch it off and focus on the presentation. Yeah, so I have mentioned we will be talking about drones, but just to let everyone, these are not toys. They technically refer to as remotely piloted aircraft systems because they are really aircraft systems. That's the term that is used, especially from our regulator, which is the Civil Aviation Authority. But so that everyone is on the same page and the presentation can flow easily, I will refer to them as drones. As you can see from the picture here, these are not your typical drones that you buy from your next door shop just to fly as a toy. There are a lot of regulatory requirements around this aircraft, starting from registering it and getting it licensed, same as your vehicle. It also has a license tag, same tag that aeroplanes have, a ZT number. You need to operate it under a licensed operator. So if we are operating under ESCOM, ESCOM has to be licensed, have an aviation license to operate these things. People operating them as well needs to have licenses as drone pilots. So I will also cover all of that as we go on with the presentation. I think that covers what we're talking about here. And on the AI aspect, is us trying to optimize our operation, which will be covered in the presentation. So let me just go to the next one. So yeah, I just wanted to share a bit about myself and how to feature in this drones and AI that we're talking about here in this talk. So as I've been introduced, I work for ESCOM. I'm a research engineer there. We started working on drones in 2018, where we conducted. So the idea there was just to explore this technology and see if we can leverage some benefit from it. But previously, the technology being new and it wasn't developed to what it is even now, there were a lot of technical challenges and things we needed to understand, and a lot from a regulatory side in South African aspect, which is SAIEE. So those are things we needed to deal with. And once we collect that amount of data that we wanted to collect, should it be images or videos, what do we do with that? How do we analyze that? Where do we store it? Those are the issues and all of that we needed to cover when we started all this research. And so as a result, because the technology wasn't that developed, especially on the data analysis side, people are still working on it, whether pilot projects, research, there and there. We're also doing the same as well here in South Africa. So I have attended a short course that was offered by University of Stellenbosch, which was called Power System Data Analytics, which is mainly an introduction to machine learning. Subsequently to that, I did another course, an in-depth one now in artificial intelligence, that was offered by a Center for Development of Advanced Computing in India. So that's just an introductory aspect of me and how I'm involved in this. I'm still involved in the research phase of this project, and I've been involved since the inception of this project. And I will share more as we go along with the presentation. Just a disclaimer, some of the images here in this presentation come from the internet, but make sure that I try to get images that are free to use, that have no copyright infringement or any of sort. Some of them do come from our field operation, from our testing, like the image you saw in the previous slide from the title page. That comes from our testing, so that's our own image. And the information may come from various authors, especially when we look globally on what is happening, and some images. But I just to declare that if you see something familiar, maybe it comes from somewhere else, it does not mean everything that is here is ESCOM's work or what we have done. Just to acknowledge a few people or organization. First one is ESCOM. Obviously, without ESCOM, I wouldn't be sitting here talking to you guys about this. they offer this opportunity. The work that I'm talking about is work that was done for Eskom with Eskom people. We collaborated with line divisions. As I've mentioned, I work for research, so line divisions are our clients. So we worked with their field teams, especially when we go out on site to do some tests. So those are people we work with. But more especially, I want to also acknowledge Eskom RT&T team. I know maybe some of them are attending. This was a teamwork, so this is what we have been doing and continuing to work towards to develop more solutions. And also SAIEE, particularly the Sendai colloquium, the insights that were shared from the colloquium are also incorporated in this presentation some way or somehow, one way or another. So I just want to start off by talking about the focus of the utilities. So with the aging infrastructure, increased demand, there are a lot of challenges. It's not, and they are not just unique to Eskom. Most utilities are faced with similar challenges globally. So the focus is just to increase the reliability of the network and also reduce cost. So operate the network efficiently, which is a challenge when you have aging infrastructure and you also have increasing demand. So that's why it's always a push to look for alternative solutions to try help us do this. So one may ask why we even want to inspect power lines. So there's a huge reason for that. Firstly, as I think it goes back to the economic side of it. To lose a power line cost a lot to restore that power from the business side now. And also from the customer side, if you're a customer and you rely on our product, which is electricity, and where power line trips due to a fault, then you're out of operation. Some lose millions per hour, depending on the scale of their production or whatever they're doing. So we try to ensure that the line is reliable and is ready to transmit power whenever power is available, especially during these times that we have. We wouldn't want to have constraint at the power station and on the network. They find that the power station can give us enough power, but a line is down for some reason and we can't transmit that power to a customer. So there have been standards to just ensure that everyone is operating the network accordingly to those standards, mainly to guide designers, the planning, to ensure safety, reduce risk, and make sure it's reliable. All of those issues are taken into consideration when developing standards, and utilities or any system operator needs to comply with those standards. And within the organization, you also develop your own standards that you need to comply with. So to do that, we have few modes of operandi, so we do it in different ways currently. So these are traditional inspection methods. We inspect our lines using helicopters. These are helicopters fitted with sophisticated cameras, which are multispectral. You have a lens that is an infrared lens designed to pick up issues with hotspots. If there's any heat issues on component or a joint, then that's the camera that helps us with that. We also have a camera which is a UV lens, ultraviolet, yes. So that is designed to pick up corona issues and also just a normal visual still image and videos that we use to see all the visual defects while the helicopter is flying along or over overhead line. So the inspector sitting there will be able to control that gimbal and look at those issues and capture those problematic areas that they pick up. The other method is for inspectors to drive on off-road vehicles while capturing those issues using handheld cameras, binoculars, all sort of tools, and noting the defects down on the paper, whatever system they're using. or else walking under the line. And this is especially for distribution when you need to also check structure integrity or have contact inspection, check some of the things. So they also use binoculars to look for other defects that are high up on the structure. But there are a lot of limitations on this, since you can't see anything that is above the conductor or any component if you're looking at it from underneath. For Powerline inspections, we started, as I mentioned earlier, the project started in 2018 with a simple, we were saying at the time, drone technology can help improve situational maintenance, resulting in cost savings, as I've mentioned before. So we're saying if we can deploy drones, be aware of what is happening, any issue of the line in time, so we can repair it, and also do everything at once, since we have such a vast network in South Africa. So then that's the prioritization will go to critical areas where we have issues, and while doing so we can save some money or reduce our operating costs. So that was the hypothesis we had when we started with this project. I will move to the next slide, hoping that I'm still audible and my screen is still being shared. I don't know if I can get an indication of that.
All fine.
What we do when preparing to go and do inspections, just quickly go through over this again. We will require maps and files that tells us where our lines is or where we cross, and we use this for applications, especially to the regulator, especially if you're going to fly and control airspace. This is required, and then when you get on site, you need approvals as well from people you'll be flying next to or over their properties, also part of regulatory requirements. During the flight, we use two people for this option. I just had something, I'm not sure if I'm...
All fine, keep going. It was me coughing, I apologize, I muted myself.
Okay, I thought, all right, yes. So we use two operators. One is a pilot, who's just controlling the aircraft, and the other one is the inspector, which is controlling the camera and looking at the defect and capturing all the image and videos as required. And then post-flight is when now we take all the data, when we look at the defects that are there, then do a report based on that. So this is where now AI comes in. We want to automate all of this. Once we're done with that, we go back to automate the flying itself. And we have tried to also digitize some of this. We'll just share as we go along with the presentation. So during our proof of concept, which is a number of field trials we've done to do this with the team, we did it in two phases. The first one was done by ESCOM staff, mainly the team from research, collaborating with the line division teams. We had a very narrow time frame for this one. This is what we managed to do: 2 lines from distribution, 31 kilometers, and this number of structures, and for transmission 3 and these distances. And the second phase, we use a service provider to inspect our line. They had a longer time frame, so this is what they managed to do during that phase, up to 135 kilometers on distribution and 90 kilometers on transmission, in a number of lines, because we were just selecting lines based on the protocol we're following, and most of these lines are in the terrains that are not easy to access for us, so that's why we're using these case studies for that. During these operations, these are some of the images that we captured, and you just want to show what we get from these cameras. You get a thermal infrared, which are used to capture thermal issues, and this is still infrared. It's just that we chose different color spectrums, We also have a UV camera, which is looking at the corona issues. I think most people here will understand what corona is, but for those who don't, I don't think it matters. I do not intend to discuss what corona is, but this is what we use to capture that. The line you saw previously was in KZN from Majuba to Mvolozi. It's a line that is designed at 765 kilovolts. I think it's currently operated at 400 kilovolts. So it's a fairly new line. These are some of the issues we picked up from that line. Like you can see the spacers, some of them are already loose, which may cause issues going forward. And the over-talking as well, you can see the breaking conductor strands, and this can lead to breaking of these conductors. We may almost take the whole bundle down if this continues. So those are sort of issues that you will pick up with these things, which you wouldn't see from ground or even from a helicopter. Very difficult to see this sometimes because you fly from a very high angle. And on the distribution side as well, you see such things as these post insulators being broken. You can see this from ground. So these are just some of the examples I just wanted to share. Like I had mentioned earlier that we're doing mainly for economic feasibility. So that's why we're doing this research to see if it's really feasible to use drones for inspections. So the question comes back again. If we look at just an hourly rate, we will say a drone is cheaper than a helicopter, but the problem here is that the drone takes longer to inspect, which then results in a high cost for a drone. This is when we did our analysis, then you can see that the drone is really expensive than a helicopter, especially for long transmission line. We use financial indicators that are well known, your return on investment, internal rates of return, net present value. I'll discuss this as we go on to the next slide, but these are things that we looked at. Again, just pardon me for using dollars, is because this information has been shared on a global platform where we had to change our figures to dollars so everybody can relate. So you can see that drones, which did say that we refer to them as RPAS, are higher per kilometer than a helicopter. So we simulated on a financial model to develop a business case for these different scenarios. The first one was looking at the current helicopter fees that we have in ASCOM that we currently use. If we continue using it for the next 5 years and or replace, you can clearly see that all our and if you look at buying a new fleet of helicopters, can I confirm if I'm still audible? Because I just saw a notification. I just want to check if everybody's still with me. Yeah.
Yes, you're back.
Okay. All right. So, and we looked at if we buy new helicopters or invest in new drones. So we look at a longer time frame now, which was 25 years, which is mainly the lifespan of our helicopters. We still see that we have a negative ROI, which tells us that this investment will not yield good results, even though IRR is positive, but it's less than a discount rate, which is still negative. It means with the net present value, you're still losing money. That's why NPV is negative here. But an interesting case is when we eliminate driving on site, which is a lot of driving on site. There is a up and down, which takes up a lot of time and also consume a lot on our resources. So if we eliminate that, we see that we can reduce our operations by almost 50%. That's why we have an ROI of 49%. The ROI that is positive and a net present value of over $4 million. I will move on to the next slide, hoping that I'm still audible. So on this slide, we just summarizing what I've discussed. We're saying that drones are not feasible for longer lines, but you can apply them for shorter lines, and especially in cases where helicopters are not permitted to fly over. Examples of those are national parks and game reserves as well. So those sort of areas and residential areas, dense residential areas, you're not allowed to fly helicopters there. So then a drone is no-brainer as an alternative for that, because any line that is less than 5 kilometers, we see value when we use drones currently without any automation. So we just have to improve on our strategies, how we fly this and approach. We also have BVLOS now, which is beyond visual line of sight. We can extend our range of flying and integrate all the automation that we will discuss going forward. I'm showing a video of the actual inspection when we inspected one of the distribution line. But while this video is playing, I would like to confirm again if I'm still audible.
Confirmed, you're still audible.
Okay, all right, that is great. So this is mainly this was done for distribution. I just want to share something about distribution. The case is a bit unique since they still require a physical inspection in most of their components, pole-mounted transformers and all of that. So their inspection philosophy will include ground inspection. We cannot replace that, but we just want to incorporate drones in doing that. So we model that again, including both sides, and we see that that will definitely yield results. I think it has about an ROI of 27%, but we'll see as we go forward on that. I think there's a slide talking to that. So that's when we were doing this proof of concept and looking for distribution. Yes, this is a slide. So the quantifiable benefits for transmission, if we eliminate driving and we introduce automation, we will then reduce our maintenance cost by 30%, which is a huge reduction if you look at the scale of our operations, and we're talking millions if we look at this 30%. And for distribution, the reduction is at 27% if we incorporate drone to what they're doing, because they are not using helicopters already. So this will be an improvement on what they have already. Again, I think I alluded on this, that we have tried to take care of some automation in the paperwork of approvals, which is pre-flight and flight maintenance. This is the app that we developed in-house, just tested during the proof of concept. We will address these issues if we had to go forward. And there is a lot of improvement that can be done on it to automate it and link it to other systems as well if we need it. But the idea was just to check if the inspector is on site, how it is to get approval, and also because there's a lot of paperwork if you're a drone pilot or any pilot that is needed. And if we have a system that can do it digitally, it will improve our operations. As I mentioned earlier on, that we use a service provider and we did it ourselves as well. So at this stage, we wanted to see if we outsource or insource, and the business case told us that insourcing is a better option for Eskom, even though some services like battery management or aircraft repair may be outsourced, but the entire operation should be insourced, should be done by us at Eskom. Now we want to look what is happening worldwide. What are other utilities doing, or even other innovators doing in this space? So this is where I start. I hope I'm still audible. So I'll start by just sharing what the literature says, literature review. So as you can see, says drones offer flexible, cost-effective solution. That's why every literature will be mainly talking about that and saying that. Unfortunately, when we did it ourselves, it's not that cost-effective unless you introduce automation. So that's the case. This is where we are. But that's what literature, every author or publishers or everybody that has done a case study or pilot projects, it's what they're publishing. So most utilities are testing and doing similar work to what we're doing at this stage. And to highlight a few, Navigant Research predicted that 13 billion a year will be on drones by utilities. This is by 2026. Countries that have widely adopted drones, especially to inspect power lines, and not that they are fully operating them, they still are exploring as well, but mainly Australia, China, as you see them. To mention just a few, China has done over 50,000 kilometers of transmission line using drone. In UK, including when you look at Wales and England, combined, they've done over 11,500 of kilometers. So again, the need to automate and reduce costs is driving digitalization and the digital transformation in Eskom and elsewhere in the industry. Mings, am I still audible? Sorry for keep doing this, but I just want to check. Clearly there is a problem. Okay.
Yes, you're audible, you're clear.
Okay, I'll just
You
go
actually,
on.
it's been pretty smooth. You've been pretty smooth for the last 10, 15 minutes.
Say that again.
Clear for the last 10 or 15 minutes, no problems.
Okay, no problems. Okay, thanks. So I was just saying this, the problem that we're facing to reduce cost is driving us towards the digitalization and digital transformation. We want to automate things. We want to incorporate intelligence and decision making that will make our life easier and improve the reliability of the network. So this is what is happening in Eskom and in the industry at large globally. Our research methodology currently, as you have indicated earlier, we want to detect these defects or abnormalities of overhead lines or power lines. So when I'm talking about overhead line, I'm including all the power line components and attachments. So we want to use AI or AI-based models to help us analyze those images and videos, classify them accordingly, if this is what, and classify the defects, if this is healthy or not. So this is what we want to do when we want to improve accuracy and efficiency in this operation. But before we talk about what we do, what is AI? I think everybody has heard of AI, everybody talks about it, but what is it exactly? There is so many definition of it and literature. There's a lot of that you can say. I have got one definition here, you can read on it, but it essentially says that we want to simulate human intelligence in machines. So we want to make computers specifically to do some tasks that a human will do and have a same thinking capability to human. In some cases, there are publications that AI is more intelligent than an average person now, so it's sitting above average. Still not at the highest level, the way people with highest IQ are, but above average already. So here I just wanted to show some subsets of AI, key subsets, and especially those that are applicable to what we're doing here. We have machine learning and especially deep learning. This is where we're focusing. This is what we are trying to make use of and to create a computer vision so we can then have a system that can see as much as our inspectors or our analysts can see and tell us what is wrong. In future, it must be able to tell us what should we do going forward. Here I'm showing some of the examples of AI, just to break away from this long ESCOM talk. We all use AI, I believe, if not all, most of us, and we interact with it daily, even on your phone, like your smart locking system, your face recognition is the same thing as AI, another subset of AI. I believe we've seen what Boston Dynamics has done on robotics, where they developed a number of robots that were initially designed for rescue operations, I believe. So they have human capabilities and they mimic human movements. And they have now developed to a very advanced stage where they can do amazing things. On the other hand, we have humanoids. These are AI with human intelligence, which can have a natural conversation with human. They're trying to just mimic all human aspect, excluding emotions. I think that's the only thing that there hasn't been any solution for it. I'm sure we know of, let me just stop this for now because I want to click on this. I don't know if it will allow me to go on YouTube. I wanted to show a video. Okay, if it doesn't, that's fine. I'm sure you know of okay, it's playing on the screen, but I will just stop it. Amika, Sophia, all of those humanoids, how they've been tested, interacting with public, things they would say, some very amusing and fascinating. Then it just tells you the advancements of AI. And the video that I wanted to share here is Amika when he responded to what she thinks of AI taking over humanity. I think the question was along those lines. So the response was very shocking. I know there's a fear around AI taking over us, and her response was confirming that in a way. But anyway, this presentation is not about that. So going back to what we're doing, this is the work that we doing, trying to incorporate AI. If you see here, we have this tower with insulators. We're trying to identify issues on the image that was taken. So automatic diagnostic tools based on AI are being developed to identify wire accessories and insulator defects. These tools employ object recognition models and deep learning techniques that I've already mentioned to just ensure that we are able to pick up these issues. Elsewhere, this is what I've also picked up or learned off at the colloquium that we recently had in Japan, in Sendai. So a lot of utilities, especially Asian utilities in Japan, busy focusing their efforts into this, and they're doing similar things than what we're doing. Some are at a more advanced stage than us, and we also just looking at what can we leverage. So they're developing these solutions. Papers that were presented, they include on object identification, defects identification, or conductor defect identification, because models, this is a very unique case. It's hard to develop a solution that does everything. So you had to look for or try to extract certain features specifically for that particular component. So some are just focusing on a conductor or a wire. others on insulators, and then we will look at integrating all of that later on and see if we can have one solution that can do all of these things. And others were presenting papers on automation, where now we're looking at flying drones autonomously without any pilot and without, so autonomous flying is different from automatic flying. I think we refer to automatic flying as when we program a drone. So we have a certain path that is programmed on a drone that it needs to follow. Whereas autonomous flight, a drone makes decisions while flying, like a pilot would do. If you see an object, you do this or that. This is how you track a line, and also adjust your cameras, because this system talks, the autonomous one will want to automatically adjust cameras and fly a drone. So it has to do everything at once. And the results are impressive from what they've done so far. I was quite impressed, and the accuracy that they're getting. Whereas here at ESCOM, we're still focusing on the insulator and components detection, which we're also getting quite good results. They're focusing on other things, and there are people who are focusing on the same thing that we're focusing. So I just wanted to share the advancements that are happening globally. This is, I think I'm not going to spend time on this. It talks to what I've already shared. You see, you've got line defects, we've got component defects. This is where we currently are at this stage here in South Africa. We're trying to develop these tools, and also we want to quickly move to this one. And there was one paper that was working on this. So computer vision is what I've mentioned, which is now enabling a computer to sort of see things, well, things that you would see. So that's why we call it computer vision. That is developed with deep learning models. So like as I mentioned earlier, you extract certain information that you will use to teach that model, and it will then learn and be able to see those components whenever you push through an image to that system, and tell you if it's healthy or there's a certain issue depending on classification that you have put in your model and how you have developed your model. And another aspect of these is that there is generative AI now. Generative AI, it's that AI that can generate content. I think ChatGPT is one of them. On a language basis, it can generate a lot of content. So the generative AI keeps learning from the information that you feed and can be able to even generate more insights. And with this one as well, we will be leveraging that in future, probably going forward. So yeah, I wanted just to show an overview, high-level architecture of this identification model that we're developing, or what we're doing here, where we will have an image as an input. We're using various libraries. One of them is OpenCV to read this image and to split it into layers and put it, and just go through this. I don't want to be technical in this presentation, but there is a lot of work just to first get a picture into a computer, and a computer recognizes what it is even before teaching it how to teaching that model to respond, and then help you solve your problem. So these are just samples of what we have done currently. If you see here, we've got these strings of insulator. We've got one string here. And for each disk, I know it might not be visible on your side, but if you look at the image itself, not on the presentation mode, it's clearly visible, high definition. It will tell you you've got a flash over mark here, or you've got a broken insulator, like it tells you, and it tells you a confidence level, 95%. So that's how the model operates at this moment. And also we can do multiple strings at once, so it doesn't matter how many strings you have on insulator. It does the assessment per disk, and it gives you that. which is what we have. So, but on the user interface side, we still have to develop that you don't need to sit and look for each block. So you can just summarize and tell you the number of issues in this insulator and location, and may probably give you in a written report. We can use generative AI language-based model, same what they use on ChatGPT, to generate automatic reports. You can even get a full report based on this model of what it has analyzed. Yeah, with computer vision, again, it uses images and videos. There's a pre-processing. This is mainly because we have a limitation of data, and it's unstructured data, let me put it that way. So you will do a lot of things before you even put the data into the machine and teach your algorithm. So in such things as data augmentation, data annotation, just to standardize and normalize that data so you can use to teach your model. So that's a quite intense work that you need to do prior. So there's collection, there's data annotation and documentation, and pre-processing, resizing, normalizing, formatting. So all of that was directed towards that. So there are libraries that we currently use. I'm going to mention a few, all open source, not try to promote any products, just to maybe share an idea of framework or what we're trying to follow here. We've got PyTorch. This is a deep learning framework for building and training models. So it's just a foundational framework where we build these models. We've got a computer vision one, a Datatron. So it was built on this one, but now it has some capabilities. This is a Facebook built, and it's open for everyone to use. So Facebook Research have built these models, Datatron, and it's open to use as well. So we also leveraging in that, and also tweaking it and incorporate and reprogramming some aspects to suit our needs here. You will need hardware, GPUs, TPUs. So we're leveraging on cloud-based solutions because big companies have built these things, high computing power. So they have platforms for you to use those computers online. Otherwise, you will invest a lot just to build this infrastructure, So to expect that, because we want to produce solutions quickly, we're leveraging on what is in the market now, which we use computing power that is sitting somewhere else here. We're using a cloud solution. It's even same for data storage. And the good thing about this platform, most of them, the ecosystem is integrated. So there is a number of libraries, APIs, and many other things that you need to develop, but most of them are able to integrate that into one platform that you don't need to struggle downloading many different things or doing a lot before you even get to developing your solution. So that is another advantage of these open source tools that we're using. This is just on object detection again. I wanted to highlight here which models we're using. We're using fast CNN to be able to identify objects. For our cases, insulators or defects on insulators. So here's just to indicate, it doesn't matter how busy the picture is, it can identify what you're looking for, what you have taught it to recognize. There's multiple layers for the deep learning and how you get to analyzing pictures. So I'm just gonna skim through this, and I have talked about these pictures when I showed some results there. So these are, I think in this picture, it's more visible to see the flash mark, and it does tell you you've got a flash mark, flash over damage here on this insulator. So that's now a result of that defect identification model using fast CNN that you're developing. The post-processing side of things is when we have all done the inspection of the entire line, we take the images, a batch of images, put through our algorithms or models, then it just process all of those images and spit out the results or the reports of the entire inspection line. This is what we busy with. There is another aspect which is real-time processing, where a drone can see defect as it flies, but usually this needs high bandwidth for transmission. You need to transmit that to a ground station or back to a control room over internet, so that when someone is sitting there can visually see what a drone, a drone will flag those issues and you can note them. But I think for us, we mainly focusing on post-processing for now, rather than real-time processing. So we can always process our data after finishing our inspection. And already, I think, edited on this one, talking about automatic reporting. So this is when now I mentioned generative AI, language-based AI, using that to probably generate reports that tells us that we had these issues and at this location and that. More than that, we want to integrate these reports with our reporting system, so where we can issue automatic work orders. So if an issue was picked up at a certain location on a line, it is critical, then you do this processing. Those results will go to that work order management system and start issuing those work orders for those problems to be solved or resolved before they result into catastrophic failures, because it's more expensive to restore a line or deal with the failure than going there and changing that component that is already defected, that we see might cause us some problems. Future of power line inspection. So as I've mentioned, we're still in the research phase. So we're continuing with research. That's not us. When I'm talking about us, mainly sometimes I'm referring to global industry and the utility area. So the use of drones for power line inspection is still in its early stages. I think I had mentioned that. And further research and development will continue to make more viable, especially if we want to increase efficiency and economic feasibility. So that's why I talk about greater efficiency and value for money. So there is value for money even if when we use them now, especially for shorter lines and other applications. But going for longer lines, it's still not that viable. One factor that I probably forgot to mention is the regulatory requirement, but it's easy to prove your case once you get there, because if we want to fly this drone autonomously, we need to prove that to the regulator. Maybe we can get licensed to do that. If not, I think for now, I think it was last month where I read an article that one of the companies, drone service companies, that they're focusing on mine operations, did get an approval for automatic flights. So now they can program a drone to do inspections. So it's not fully autonomous, it's automatic. It's easy for surveillance and all of that, because you can program a drone to fly on a certain route. For power line inspection, that is not applicable based on the condition that the drone is flying in. The drone needs to always adjust according the line sex. The drone needs to go with that sec or up, and fly around structures. They need to avoid certain things, and also there are a lot. There's a lot of variables that it's not feasible to program a drone and do this inspection. You rather have it flying more like autonomous cars that are being developed, so be able to make its own decision and do all of those things. So that's what we're focusing on. So going forward for power line utilities, it's just mainly about balancing efficiency and cost. especially given that most infrastructure is aging. So that's what we're trying to highlight here, and improve these digital technologies that we're developing. Our aim here in research is to now start looking at all other components like your bolts and nuts. If a bolt is loose, you should be able to also detect from this system. If your damper is cracked, you still need to train your models to do that. So we want to go to that aspect and include MV lines and LV lines, because the model now is trained mainly on high voltage lines, as you can see. So all of that still need to be done, and start incorporating your conductor, whether we via collaboration or whatever, we develop our own, so that we can have a suite of these models working together to give you one report on the entire condition assessment. So that's what we're talking about, and also work on autonomous flights, as I kept mentioning that this is where we see efficiencies. If these drones fly themselves, which they will, it's possible, they can fly now, but based on a unique condition of Powerline, we still developing that solution further that has already been developed to fly autonomously. So we ensure the other thing is the conductors are so thin, it may be easy to miss this, but we use LiDAR sensors for that. There are a number of sensors that are needed to be used to ensure that a drone can pick up and keep a certain distance to this line, follow the line path, sex with it, and keep adjusting a camera accordingly. And this inspection will be video based, where we will have an IR video, visual video, and if we have a UV camera there, a camera recording corona activities, then you take those videos, you put them into a model again, and it picks up all these issues, which is what one of the papers there was talking about, the one that was focusing on conductor defects. They use a video footage rather than image, and they segment the video into multiple images and start analyzing them, but not a person. A machine does that. You only get results that you want. With that, I think I've reached the end of my presentation. I hope I'm still audible, and apologies. I do really apologize. I know there were a lot of interruptions, and probably you missed out some of my discussions or presentations based on that. Thank you all. Thank you for your time, and hope you got some insight of what we're talking about. Back to you, Wings.
Sianda, hi, man. And that was fantastic. Yes, don't worry, the interruptions didn't detract from the presentation that much, and everything got smooth for the last half an hour, so fantastic. Okay, so I'm going to just go through some questions here. We've got one from Rai Walter-Sequete. He'd like to know how fast a distributional transmission line can be inspected. Is there like a kilometer per hour rate that you typically have?
Can you just repeat the question?
So he's just talking about sort of for a transmission line or distribution line.
Yes. Okay.
Have you worked out what the relative speed, a typical speed per kilometer is?
Oh, all right. Not necessarily. That is based. Okay, let me just try explain it this way. We have done it internally. We're probably doing it merely relatively low speed, because you need to control the drone manually and move it around, get the right angle to capture that image, and move around, try to capture both sides of the structure, especially if you are on a tower, and then fly along the conductor to the next structure. We will try to cover at least 3 structures, which gives us about 1 kilometer before having to land and change batteries and move to the next location or something similar to that. But with experience, you get to do that much faster. When we used a service provider, we had to spend about a week with them trying to teach them or make them understand, get them to take pictures at the right angle or whatever it is, because they did not have experience. They are well experienced in flying drones, where pilots are good, but when coming to Powerline, it's a different environment. They were struggling, so we had to do them. But after a few weeks of that, they picked up again. You see, as said, I did include it in this presentation, the speed being improved of inspection. So they started doing covering more distances quicker. For I think for a 275 line, we were able to do about 20 kilometers or so a day. I think with two teams or 2 drones. So probably that can give you an idea also. That's on pure manual flights.
Okay, so that's 20 kilometers a day per, so 10 kilometers a day per drone.
Yeah, more or less the same, yes.
About an 8-hour day or 6-hour day?
I would say about 6 to 7 hour day, yeah.
Yeah, all the setting up and overhead costs and all that.
Yeah.
How far is the controller from the RPAS? This is from Haggai Satole. When it's in use, and does the drone have to be visible at all times?
Okay. So the controller, by design, most of these drones, I think they can be 15 kilometers or more away from the drone. But that's if it's a straight line with no interferences and all of that, which you hardly get that. And on the regulatory side, if you approve for visual line of sight, so it means you can only fly up to 500 meters on either side. So you can fly that way 500 meters and 500, so you can do a kilometer on one flight. But we do get licenses that approves you to fly beyond visual line of sight, and you then can probably push it. I think our case, one case study, we were able to do about 3 kilometers away from the pilot.
Okay.
Yeah.
What extra skills are needed to use the drones, and how is this affecting current staff that is technologically less inclined? And how difficult will it be to roll this out, and how is it accepted by the maintenance and inspection crews? Is there any resistance to change?
Yeah, that's a good question. Thanks. Yeah, look, it's new to our environment. There are different school of thoughts. There is some resistance, but there is quite a lot of appetite. On the other hand, people are keen to use these tools and see, but it's quite challenging. It needs a lot of time. You need to invest your time. Firstly, you need to go on a training, which you then get licensed as a pilot. So it involves ground school, which is pure theory on aviation theory, several modules there. Then the practicality of it, so practical flying. But I'm aware that the regulator, Civil Aviation Authority, is changing the licensing. So now there will be certification instead of a license. I'm not quite sure how the curriculum is going to change, but I know there will be some changes. But those are key. That's what you need. And to do that, you need a lot of time, especially to practice and go and do, so you can get to a right level of skills and you get tested on that. So you need a lot of time to do that. So if you're busy and you have your day job and you're not given time, you're not going to manage. In our case, we had a number of people not passing or getting their licenses, mainly based on that. And again, you after that, you need to mainly, I think it will require you to focus fully on it. So I think on our business case, what we recommended and what we are showing, that you rather have people that are just employed as drone pilots. If you want to convert some of your employers to that, but their primary role is to fly these aircraft and do inspections, and then you can have systems analyzing that and that. But that will quickly change again. As I've said, there is a lot of development around automation. So once that is done, these problems will be insignificant.
Okay. So these are questions when you were talking about the driving portion of it.
Yes.
What strategies does the speaker propose to eliminate or minimize road travel, band cost savings? In the estimate savings for transmission and distribution 30% to 27% respectively, has a model completely eliminated the road travel component or cost?
Okay, I didn't quite get the whole question, but I think okay.
So you basically, when you were talking, you were saying that the major cost is still to do with it's time consuming to do drone flying, and you still need to have a vehicle following the drone.
Yeah.
And a big component of the cost is, well, 30% of it roughly is travel, ground travel. Is there any way of eliminating that? Well, we did talk about the line of sight, I suppose, eh?
Yes, so that's why I think in one of the slides we put up strategies. So we kept altering our strategies, trying to work around that, especially to increase speed as well, because speed counts. The more you spend on a line going there daily back and forth, that also increase your driving cost. So beyond line of sight, it also reduces that, and probably deploying multiple teams at different locations. They don't need to move around. So even your positioning, if you're beyond line of sight and you see you can only fly up to 3 kilometers, maybe you may try to position yourself where you have 3 kilometers flying that way and another 3 kilometers flying that way. Also, the battery is your limitation there. But yeah, those are sort of things that you can do. But the ultimate solution is autonomous flight, where you will probably go on site and just release a drone to fly until it sees that it doesn't have enough energy or battery is about to die and comes back to you. But again, on the other hand, what I didn't mention there is, I think it's one of the things I proposed back in the days, but there is an advancement in that. There is a university in Denmark. They have been publishing a lot of papers and I've been following them. They are working, they are funded by the state and other utilities, and in Denmark, they developing a self-charging drone as well. So doing this autonomous flight, but a drone, when it runs out of power, it hooks on the conductor and it charges using magnetism from a conductor, and then once fully charged and clamps and continue with the operation. So once that comes to commercial stage, then you see that these things will be done easily. It's also to do that again, they're using AI. It needs to know when to do that and how to identify a conductor to make sure it clicks correctly, all of those things.
Interesting. I wonder if that's like described as non-technical losses or technical losses. But anyway, there was a question from Hakai Sitole. Will Eskom adopt this technology? And then the second part is, when is the POC expiring?
Yeah, yes, the Eskom is going ahead to adopt the technology. Obviously, there are a number of things we need to sort out and get in place, and the development on the other side is going in parallel, as I've said, but they can go ahead and implement what is currently available, manual flights and all of that. If you're talking about the POC as a proof of concept, that has we have concluded that we have published, firstly, we have done our reporting to our stakeholders within the business and business case and all of that. And there is even a publication now that was published in a national conference and international ones as well.
Okay, there's a couple of questions from Walter Walwa. He's asking about sort of, I'll take it as like the POPI Act. I mean, Are there regulations around the drones going over private property? You know, he says a couple of challenges around this. What have you experienced?
Yeah, so by law, again, I think I did talk about that, but I might have been disconnected at the time. You are required to, as part of your approval, because you need an approval to do this, to do every operation. You're required to have that authorization from a landowner. If you're going to fly over a certain land that is owned by somebody, that landowner needs to approve you to do that. Usually for our case, we were leveraging on the communication systems we have within Eskom, because our lines run over farms or whatever the case may be. We know landowners there. We try to engage them and get those approvals. If it's a line that is in our land, the lease, our manager, usually the GM will sign for us. But within a dense residential area, what we will do is go sometimes door to door, just telling them what is going on. We will have notifications that we are flying from Eskom. This is what is happening. They should not worry. We want here. So just to give them comfort, we well aware of POPI Act and that we need not to capture the property or whatever it is going there. So we will do those engagements in the area we're flying in to ensure that we don't get much resistance.
Yeah. Okay, we only got a couple of minutes left, but question is this tech, will Eskom be willing to share this tech with municipalities, or I mean, I think like
I'm assuming yeah. Okay. So I'm not in a position to comment on that at this stage, but I see the possibility, but obviously it's something that will be done from a different office or different business unit, maybe on a commercialization side, or whatever agreement that is reached between two parties. Probably that's an approach that can.
Yeah. Okay, so there's a question. Huawei has a functioning system very similar to yours. The question is, why is Eskom trying to adopt its own system as opposed to maybe just buying an off-the-shelf option from something like Huawei Energy?
Huawei, yeah. So I think there are a lot of products that are out there in the market, and people will say they are there, they exist, and so, like I say, there are a lot of object identification systems or algorithms, but they train differently depending on what exactly you're looking for. Like, for instance, one model was looking at conductor defects. That is completely different. There's no model that can do that at the moment. They're now trying to use a frequency, there's just a lot of technicalities on an image to see if you can track that line on the picture. So usually what is available on the market is not fully suited to this. I think it also talks to why there's so many research and development going around currently. Otherwise, all utilities will be buying off-the-shelf products instead of investing in research and doing all of this. But what we do leverage on what was, like I said, computer vision models. Some of them are there, even though we take bit and twitch. So we use open source frameworks that is already been developed. But you still have to do a lot of development and a lot of tweaking and preparing your data for that and teaching those models to that specific case. I don't know if
there's a question around the testing of electromagnetic compatibility. Are you willing to share some of the highlights of some of the findings around the immunity around electromagnetic?
Yeah, I think we can discuss that. Certainly we can share some of what has been published. Yeah.
Okay, and are they? I mean, so I'm assuming these drones are relatively immune to EMI.
Yes, relatively, yeah. So they vary. We tested from I think 2 to 3 different manufacturers, and also different models of each manufacturer. The performance varies, but they're fairly immune unless you want to get really close. But I think with 7 meters, 3, 2, whatever it is, they're still immune because we tested at the highest level of those in magnetic interferences.
No problem. Then, what is your sort of limits around bad weather, rain and wind? I mean, I'm assuming there must be some safety limits or practical operational limits.
Generally, well, by design, they will, on the specification, say some of these aircraft, I think they can withstand wind speed of about 15 kilometers an hour. I think our limit was mainly 8. The reason for that, it becomes very unstable. Even though it can fight the wind, try to be stable, but as a result, it drains a lot of battery. Then you get less flight time, and it's hard to capture clear images because the gimbal system shakes a lot because of that high strong wind. So it's not really feasible to fly at a high speed wind. It makes no economic sense. Rain as well, it can withstand drizzling and all of that. But sometimes, again, it's not feasible if then you're going to get that on your camera and then you're not getting good quality images that you want. So, weather is a factor. It's a huge factor.
Okay. So, Sienna, that was the last question. I'm not going to take any more. We are past the time. So, on behalf of the SAIEE KZN, we really want to thank you for a really very interesting and well-presented presentation. So thank you very much.
Thank you. Thank you for the opportunity, and thanks to everyone that has attended. And
yes.
Apologies once again for the glitches that we experienced.
Yes, and a big thank you for everyone who took the time to be part of this. Yeah, there'll be a couple more coming through. So thank you very much for your time, everyone, and have a great evening. Keep well.
Bye.